Good morning, geometry. Today we get to look at section 15-5, where we get to look at angle relationships in circles. So again, our big question we want to ask today is, what are the relationships between the angles formed by the lines that intersect a circle? So again, another relatively easy section. Deals with mostly of the theorems. You're more than welcome to do the explorers, but I'm just going to go right to the meat of the matter. So if we look at page 830, at the bottom of the page is one way that we can look at the relationship between angles formed by lines that intersect a circle. And this theorem that you see on the bottom of page 830 is we have intersecting chords. We can find intersecting chords angle measure theorem. All right, well, it's very simple. If we have two secants, like we have here, or actually, in this case, we have two chords, they intersect in the interior of a circle, then the measure of each angle formed is half the sum of the measure of its intercepted arcs. Now, this goes way back to a couple of sections. So here we have, if you stop and look at it, we have two chords, AD and BC. They intersect at a point E, which is inside the circle, and we can find the measure of any of these angles. Now the picture here is just finding the measure angle of 1. We can find the other 3 if we like, just applying this formula. And it just says that if we take one half the measure of the arc AB, now sometimes they give you this information, and the measure of the arc CD. And it looks like it's their opposite ends, okay? Opposite sides of it. So we can figure out this measure right here by taking these two arcs, adding them up, and dividing it in two. So that is the intersecting chords angle measure theorem. Now again, we're going to run across quite a few different scenarios, so you have to go and think which one do you want to use. We don't have to worry about the proofs. What I have done at the bottom of the page is I've already worked out 4 and 5. Again, I probably should have told you to stop the video and work it out, but here, we want to find number 4. We want to find the measure of angle MPK. So that means we're trying to find this measure right here. Well, we see they gave us an arc angle of 61 degrees of km, and they also gave us the arc length of NL, which is 111 degrees. So all we can do is apply that theorem that we just talked about. We have intersecting, well, as a matter of fact, we have a chord and we have a secant. So we can apply that theorem. Number 5 is the same way. I'm going to let you guys just look at that. Like I said, these are not that hard. It all ties into the theorems. All right. The next one is on page 832, where now in this case, if we have this is a tangent secant interior angle measure theorem. So it says if we have a tangent, again, BC is a tangent, and we have a secant or a chord. Here we have a secant of AB. They intersect on a circle at the point of tangency. So B is the tangency point. Then the measure of the angle formed, again, they're talking about, in this case, the measure of this angle. The measure of this angle formed is half the measure of the intercepted arc. So you can figure that out. So the measure of ABC, this angle right here, equals 1/2 the arc of AB. All right. Like I said, these are not that hard. You just got to sit down and ask yourself, which scenario am I dealing with here? And down below, I've did the examples for you. You're more than welcome to copy them and study them. Now, be very careful when we get into examples because they start throwing a lot of information at you. You got to be able to decide what are we trying to find. Okay, just take your time. It's really not that difficult. All right, that is the tangent secant interior angle measure theorem. All right, the next one is the tangent secant exterior angle theorem. And we have three scenarios here. So here if a tangent and a secant, or if we have two tangents, or if we have two secants intersect in the exterior of a circle, that means outside the circle, then the measure of its angle form is half the difference of the measures of its intercepted arcs. So again, if you look at this situation, we have three different scenarios. The first one, we have a tangent, and a secant. The second one, we have two tangents. And the third scenario, we have two secants. So they use the same theorem up here. So again, like say, for example, if we're dealing with a scenario of a secant and a tangent, we can find the measure of angle 1, that's the exterior angle of measure 1, equals 1/2 the difference, that's this minus sign, difference of the measure of arc AD minus the measure of arc BD. Okay, so I'll let you guys look at these three scenarios. You guys can decipher that. It's like I said, this is mostly common sense. You'll have no problem doing this stuff. Now, in example 3, they gave us 3 examples that deal with each one of these scenarios. Example A ties into this example. Example B ties into this example. And then your turn 8 ties into this example. So again, there is those problems. I'll let you guys look at them, try them, stop the video, try them, and see if you get the same answer. All right. So that is the tangent exterior angle measure. Now the next thing they look at here is an explain for. Please forgive the mess up of my picture. Is going back and recapping and adding some other information that we've learned in this section is understanding angle relationships in circles. Again, here is some other examples that ties into the rules that we just used. Again, please forgive the writing here because somehow or another when I printed this up, it just gave me a bunch of scrambled letters. So there is your angle relationships in circles. It's on page 834. Then, with that said and done, I worked out example 4. A is already done for you. B, I filled in the blanks for you. And letter C, or excuse me, your turn 10, I have worked it out for you. So again, now this one is a little bit more multi-step. Just pick it apart, think it through, and you should have no problem. So that is section 15-5, dealing with the angle relationships in circles. All right, guys, I'll post this video and you guys can watch it and do this section. Catch you later. Bye.